So now it's recording. Okay. So, what is it? Yeah. So it's 4 ln 2x minus 4. Any question about this one? The third one? Okay, hopefully not. And the rest I will leave it for you, so it's something to practice on. It's important to do them. Yeah, I gave you this question as well yesterday. So this is similar to the one I did yesterday for you, which was, I think it was x minus or x plus 4 over x plus 6 or something like that. So this same idea, if anyone solve it, so this is x minus 8 and the denominator is x plus 3. So I want something, I want to make the top as x plus 3. So if I add 11, then I will get like plus 11 minus 8 is plus 3. So if I add 11 and subtract 11, then, well, and there's a dx here. So this is going to be is x plus 3 over x plus 3 minus 11 over x plus 3 and the lovely dx. Yeah, and this will be, you will carry on as the integration of 1 minus 11 over x plus 3, and we can make it as 11x plus 3 to the power minus 1. So minus 11 times x plus 3 to the power minus 1 dx. So now, I mean, I don't want to solve it. I just wanted to give you the idea of solving this, yeah? So don't let me finish it. Because I want to do other questions a bit harder. So the integration of 1 is x, then minus, here you deal with it to the power minus 1, and you will do it like, no, actually we can't do this, sorry. Okay. This is going to be ln, actually, so it's 1 over. It's ln, it's 11 ln. So it's minus 11 ln x plus 3, yes, plus c. And this 11 can go as a power, so this will be x minus ln x plus 3 to the power 11 plus c. Anyone did this yesterday? Okay, fine. Lovely answer. Let's see. Well, yeah, I need my board here. No. Okay, I want to do another questions for you here, which is yes. So something maybe you will say like find the integration of 4x cubed plus 10x plus 4 divided by 2x squared plus x dx. Okay, so this kind of question, as you can see, the numerator, which is the top here, it's heavy. It's the, we could call it the top heavy fraction, because the power of the x here is x cubed, and at the bottom is x squared. So it's the top heavy fraction. It's same as when we say the fraction like 7 over 5. We call it improper fraction or top heavy fraction, because the numerator is bigger than the denominator. Okay, so we call this as a top heavy fraction. And did I went through this yesterday with you? No. Okay, I just want to make sure. Where is it? Okay, so what we need to do in this case, first of all, yeah, it's a bit complicated, this question. It's not complicated, but it needs different steps. So because the top is heavier than the bottom, yeah, it's the top heavy fraction, we need to do a long division first. Okay, so that's step one. And after the long division, I will show you that we will need to use, in this question, maybe you will need to use a partial fraction. And after you solve the partial fraction, then you will do the integration. So we'll do the long division here. So this is the 4. Let's move a little bit here. Yeah. Go down. So that's 4x cubed plus 10x plus 4. Okay, as you can see here, we don't have the term x squared, so don't leave it like this. Write it down as plus 0x squared, then plus 10x, and then plus 4. Okay, this divided by 2x squared plus x. Is everyone remembering how to do this, the long division? Hopefully, I'll go through it now anyway. So we'll start with the first, the leading term, what they call it, which is here, dividing by the leading term, which is here. These two are the leading terms. Right, so 4x cubed divided by 2x squared. So 4x cubed divided by 2x squared is 2x, yeah? So 2x, and then 2x times 2x squared is 4x cubed. Then 2x times x, yeah, we multiply by this. So 2x times x, and there's a positive sign, both of them, so that's plus 2x squared. And now we subtract. Then remember, when you subtract, these signs will change. So this is positive, it's going to be negative, so they will cancel each other, so that's 0. Then 0x squared minus plus 2x squared, yani 0x squared minus 2x squared. So this is going to be minus 2x squared. Yeah. Remember, usually what I do, I put the new sign at the top here. So it's 0 minus 2x is minus 2x squared. And then we will put this down. So this is going to be plus 10x. So now the leading term is minus 2x squared. So minus 2x squared divided by 2x squared is minus 1. So that's minus 1. And minus 1 times 2x squared is minus 2x squared. Then minus 1 times x is minus x. Am I too fast? And then we subtract. Then when we subtract, this like gonna change the signs because we are subtracting. So this will be 0 basically, and this 10x plus x is gonna be 11x. So this is 11x. 11x, and then I will put the 4 down here. So this is a plus 4. Okay, 11x, now the 11x is the leading. 11x divided by 2x is, well, we can't because 11x is lower power because it's not x squared, so we can't divide by 2x squared. So basically, now it's going to become pink here. This is the remainder. Okay, I can't carry on because the power of x here is less than the one we are dividing by. So in this case, we will write this as the integration. So therefore, the integration of 4x cubed plus 10x plus 4 over 2x squared plus x equals the integration for what we got here, the answer, Which color would you like? The green. Yeah, it's the answer here. So this is going to be your answer here, which is 2x minus 1, which is the quotient basically, plus the pink bit, which is 11x, oops, just a minute, which is 11x plus 4. 11x plus 4 over the 2x squared plus x. I'll put this in pinky. This is the remainder. Yeah, and the lovely dx at the end. Are you good so far? Hopefully. Okay, so we didn't finish. This is part 1 of this question. We just need to divide. Now, as you can see here, the pink part here is 11x plus 4 over 2 terms, 2x squared plus x. So what we need to do now, change this, the pink part now, as a partial fraction. So I need to work out the partial fraction for it, okay? So work out working out the partial fraction. So what we have here is 11x plus 4. Yes, so you leave the integration for now. We need to concentrate on the partial fraction. When we finish, we'll carry on. So this is going to be, we'll take x as a common factor. Yeah, so it's going to be x. And what's going to be left here? 2x plus 1. And that's 11x plus 4. Are you okay so far? Yes, hopefully. Oh, then, so there's going to be a over x plus b over 2x minus 1 or 11. Wait. 2x, it's plus 1 actually, yes? Oh my God, plus 1. So plus 1, 2x plus 1, yeah? So now we'll say, after you do, like, you know, the denominators both are the same. So make a long story short, as they say. So it's 11x plus 4 equals a times 2x plus 1 plus b times x, which is bx, right? So then when x is, what's the values of x here? X equals, what is it? X equals minus half, or x equals 0, okay? So when x equals minus half, then we will end up with a equals, if x equals minus half, then we end up with b equals 3. I want you to work this out, yeah? And when x equals 0, we get a equals 4. Okay? Because 2 times 0 here is 0, plus 1 is 1, so that's 1a, and that's 4 here, so a equals 4. So these are the value of a and b. I will just a minute, I'll go down there. These are for you for later. Good picture. Right. Go now up. Right. So when a now fine. So now what we need to do? Go back to our work. So this is going to be move this away here. So therefore, now we can say 4x cubed plus 10x plus 4 over x times 2x plus 1 equals 2x minus 1. That's when we did the partial, the division, plus instead of the a, I will put 4 over x plus 3 over 2x plus 1. Okay, so what I did so far, I did the long division. And I get this integration here, the 2x minus 1 plus this partial fraction bit. So the pink one, I got it as a over x plus b over 2x plus 1. I found the values of a and b, and I put it, I substituted the value instead of a and b. So that's why I got this, the combination of all of these. Yes? So this is what we're going to integrate now. So therefore, the integration of this, so now the integration of all this is going to be, so the integration of this with dx, I'll write it down again, actually. That's it. So the integration of 4x cubed plus 10x plus 4 over x multiplied by 2x plus 1 dx equals the integration of 2x minus 1. You can separate the rest, or you can just put them all the same. It doesn't matter. So we can do this dx plus integration of 4 over x dx plus integration of 3 over 2x plus 1, and there should be a dx with it just a minute. Oops. Oof, dx. Okay, so now it's easy. So I'll call this I. Yeah, let's call this I. This integration. So I equals. Now, who want to help with this? So the integration for 2x minus 1 is going to be x squared. So this is the first one here. It's going to be x squared, well, 2x squared over 2 minus x. Yeah, so cancel the 2's here. So we get x squared minus x. So that's x squared minus x. And then plus 4 over x. Ali Dabi, can you help me with this? No, Ali
For
Dabi.
ln x.
Sorry?
For ln x.
I'm thinking.
So plus 4 ln x. And then the next one who want to help with?
3 over 2 ln 2x.
So plus 3 ln 3 over 2 ln 2x plus 1. Why it's over 2?
We time and divide by 2.
Yes, so we divide by the 2 here. So ln 3 over 2 ln 2x plus 1 and plus
C.
plus c. Well done, thank you. Okay. Right, so now we just rearrange things. So we'll get x squared minus x then we have plus 4, so we can make this as x to the power 4. So it's ln x to the power 4 plus ln this to the power 3, well, what was it? 2x plus 1 to the power 3. So plus, what I said, ln 2x plus 1 to the power 3 over 2 plus what else? Plus c. Yeah. Yes, that's it. Plus c. Right. There is additions here, so we can do them as multiplication. So we can say this equals x squared minus x. Well, there's plus here. Got it. Yeah. Plus ln. What we have, the x to the power 4 and 2x plus 1 to the power 3 over 2. So we can put them together as multiplication. So it's ln of the modulus here of, what is it? Please distract me, things coming up, x to the power 4 multiplied by 2x plus 1 to the power 3 over 2 plus c. Is the modulus clear here? Yeah, I just want to make it clear. Okay, plus c, and that's it. How was it, this one for you? Okay.
Yeah, it's clear enough.
Excellent. Right, another one is
Miss,
yes.
can you just quickly explain what we did in this question?
What we did, okay. Yeah. So we have in the question we have a top heavy fraction. That means the top has, as you can see, x to the power 3, which is higher than x squared. Yeah. So if the top is higher or same, even if the top was 4x squared, yeah, we need to do the long division. So if it's higher or same as the denominator, then we need to do the long division. Okay. So we did the long division here, and we got the quotient 2x minus 1, the green bit here in the answer, and the remainder was the pink one, 11x plus 4. So what I did here in the next step here, all I did here, I just wrote the integration in the new form, like the quotient is 2x minus 1 plus the remainder 11x plus 4 divided by 2x squared plus x. I'll just use some other color so you can follow me, right? So I did this, and then because this is now in this integration, I have 2x minus 1 and I have a fraction. So I need to make the fraction simple. So I use the partial fractions. So this is the pink bit. I did it here down there as a partial fraction. Okay. And so this is the partial fraction is only for the pink bit because I have a fraction. It's not simple yet. So 2x squared plus x, I factorize it as x times 2x plus 1. And then it's a over x plus b over 2x plus 1. You solve it, you found the values of a and b, and then you just substitute it back. It's like you found a and b, we go back here, and instead of 11x plus 4, instead of this pink bit, I write it down as a over x, which is 4 over x now, plus b over 2x plus 1, which is, what was b? 3. Okay, So that's how we wrote it down here. Okay. Which color would you like? Yeah. So this is just substituting all the things here. So this is the A, the 4 is the A, the 3 is the B. This is the B, we'll have the A, well that's originally there. We will X and 2x plus 1, it's basically originally was the 2x squared plus x. Okay? Now, after I have everything now simplified, I do the integration. So the integration for the original question here is equals all these parts. You can leave it as only one integration or make it as 3 because it's addition, so there's no problem. Okay, and you just solve it like that. Does that answer your question, Abdullah?
Yes, thank you.
You're welcome. There is another question now. I don't want the time to finish and I don't finish. I have another question for you. Oh, where is it? So I did this. Okay. Right. Maybe, just a minute, let me. Okay. So if we have this question, which is eight x squared plus 21x plus 13 over 2x plus 1 times x plus 2 squared. Okay, so before I say anything, can anyone help me and tell me what we can do in this kind of question? Anyone have any idea? Can volunteer? Can tell me? Can anything? Yeah, 1 minute. Okay, quickly, please. Volunteers. Huh? Abdullah, Assam.
We solve it as a partial fraction.
Yes, and how we deal with it, you know?
We split the squared for 2, then we put a, b, c.
Excellent, thank you, Abdullah. Well done, excellent. Yeah, because we have a repeated factor here, which is the x plus 2 squared. Yeah, we have this. We call it a repeated factor. Is there any delay when I'm talking or writing?
No,
Okay.
no.
Good. So we have this repeated factor, x plus 2 squared. So therefore, we can make it a plus b plus c over these things. Okay. Also, I just wanted to, as I told you, maybe you will be asked like, maybe you will be given this equals a over 2x plus 1 plus b over x plus 2 plus c over x plus 2 squared. Okay, that's important because the yellow one here, the x plus 2 squared, is repeated factor. Then we need to write it twice for each power. So that's x plus 2 to the power 1 and x plus 2 squared. Okay, so maybe they give you a question like this fraction equals a plus b plus c, and you need to deal with it. And using partial fractions, solve this, and then hence integrate. Or maybe they say find the values of a, b, and c, hence find the integration. Or maybe they just give you the integration as this, yeah, the integration for this, and ask you to solve it.
Miss,
Yes.
why we put 3 times for x plus 2?
3 times, no, what, the first one is 2x plus 1. So this is,
And B and C.
yeah, okay. So the green one here, 2x plus 1 is the first one, okay? And the second one, because it's squared, the yellow one is x plus 2 squared, we call it a repeated factor. If you remember when we did the partial fractions, then you need to write it twice. So
Yes.
first one is x plus 2 to the power 1, and then x plus 2 to the power 2. Okay, so that's why we got a plus b plus c. If that will be given to you, then you have no problem. If it's not given to you, then you need to deal with it. You need to know how to separate this or split them when you have squared. Okay?
Yeah.
Right. So now, yeah, so after you deal with this as a partial fraction, this going to be, just a minute, question here. So this going to be so it's like 8x squared. I'm not going to write the denominator. Plus 21x plus 13. Oh, I can't help it. I have to write it down. Yeah, it's the same, the yellow and the green, equals a multiplied by x plus 2 and x, well, actually it's x plus 2 squared only, yeah, we don't need to write by 1 as well, plus the b is going to be multiplied by 2x plus 1 and x plus 2 to the power 1 only, because it already has to the power 1, plus c, and c will be multiplied by only 2x plus 1. Okay, let's color them for you. Which one is the green? Which one is 2x plus 1? So this is the 2x plus 1. This is 2x plus 1. And there's a yellow one here and here. Are you happy so far? I hope so. So I will leave the substitution for you, like to find x, like when x is 0, no, x is minus 2 and x is minus half, yeah, something like this. So I will leave this for you, and after you find the thing here, these notifications really distract me. I don't like them. Okay, so we'll find A and B. So then A is going to be 2 and B is going to be, are you okay to find the values? Yes, guys? 3 and C is going to be minus 1. Right? After you work them out, you substitute the values to make the terms equal 0. You will find the value of A, B, C. It should be as A equals 2, B equals 3, and C equals minus 1. And then when you do this, when you find the values, you substitute them in instead of A and B and C. So this will be, go up here, right? So this is going to be, so 8x squared plus 21x plus 13 divided by 2x plus 1 times x plus 2 squared equals 2 over 2x plus 1 plus 3, that's the b, over x plus 2 plus, well, actually minus c, minus 1, because c is minus 1, so it's minus 1 over x plus 2 squared. Okay, so now we reach this, the purple one, after you find the values of x and y, then we need now to do the integration. We'll move this picture. Oops. So. Okay. Right, so now I'll say using partial fractions in integration. Okay, so that means we need to, the integration, so the integration of this, the question already, 8x squared plus, just make sure I'm not writing anything wrong, 21x plus 13 over 2x plus 1 times x plus 2 squared equals the integration for 2 over 2x plus 1 plus 3 over x. So we can make them separate as well, just to make life easier. I need to make the line smaller here. So it's 2 over 2x plus 1 dx plus 3 over x plus 2 dx minus 1 over x plus 2 squared. So far, so good? Right, so now this equals, right, who can help me? Let me choose. Islam, are you here? Well, you are here.
Yeah.
Hi, Islam, how are you? Okay?
Yeah.
Okay.
Ln 1
Ln what? Sorry?
x plus 1.
So ln 2x plus 1, yeah? Because we have the
Yeah,
derivative.
2x plus 1, yeah.
Yeah, so it's going to be ln, what is it, 2x plus 1. Thank you, Islam. Remember the function, this formula, the integration of f dash x over fx. Maybe it's not going to be then f of x. It's not going to be maybe in your formula sheet, but you should know it. And your test is going to be online and open book. That means you can use your notes to help you. So it's not, what I mean, your notes to help you, that means you can just write, like, for example, this formula, it will be handy for you to use it in your formula sheet. Okay? Right. So, next one, let's say, who do I have here? Let me choose someone to answer this. Yusuf, can you help me with this? How are you, Yusuf?
Fine.
Can you help with this? The second one, 3 over x plus 2. You can take the 3 outside and deal with 1 over x plus 2.
1 over x2. 1 over x.
It's like 1 over x. So if you have 1 over x, you will say ln x. If you have
Ln x.
1 over x plus 2, it's going to say ln x plus
Ln x plus 2.
Yeah, well done, Yusuf. Thank you. So this, like, I'll just write it in pink here just to show you how you can deal with it, make it easier for you. It's like a 3 integration 1 over x plus 2 dx. So the 1 over x plus 2, it's, you deal with it same as you deal with 1 over x. If we have 1 over x, we will say it's ln x plus c. So same thing, if you have 1 over x plus 2, then, well, there's a dx always should be here, yeah? Then we can say this is ln x plus 2, okay? So this one here is going to be, which color was this? 3 ln x plus 2. And then Franciscus, the last one.
Yeah, miss. Do we need to expand it the x plus 2 square or just leave it in?
Yes, the last one, because it's on x, it's a squared thing. We can't deal with it as as a ln. We can't deal with it as a ln. So
Miss,
basically,
can
we'll
we
just
take it up?
yeah. So we need to well, deal with it as the power. So this basically, it's going to be, I'll write it in pink or orangey here. So we can write this as the integration for x plus 2 to the power minus 2. Color maybe not very clear here. Yeah. So it's like integration for x plus 2 to the power minus 2. So when you integrate to the power minus 2, you will add 1 to the power and divide by the new power. So this is going to be x plus 2 to the power minus 1 divided by minus 1. You with me? I'll explain it here. So it's like the integration of x plus 2 to the power minus 2. I will put the minus here as well, just as I cut this from there. Okay? So this one here with its minus is here. Right? Same thing. And there is a lovely dx here. So this equals, I will leave the minus outside here for now just to show everything. And now x plus 2 to the power minus 2, you will add 1 to the power, so it will be x plus 2 to the power minus 1, because you add 1. So minus 2 plus 1 is minus 1, and you divide by this lovely minus 1, which is the new power. Okay, so now what we have a minus here and a minus here. So this is going to become plus. So therefore, this is going to be plus, yeah, x plus 2 to the power minus 1. Or you can write it as plus 1 over x plus 2. Because minus 1 means it's originally should be at the denominator, and we are putting it at the numerator, which is the top. So if I put it back down, the denominator, then it's 1 over x plus 2. Okay with this? So this is going to be plus 1 over x plus 2, which is this bit here. Which color you like? The green from here is going to be here. Do you understand this, everyone?
Yes, I
Yes.
understand.
Good. Yusuf, you got that?
Do we need to see or
Sorry, the sound, the voice is breaking. Who's that, Francisca? And then there's a plus C, by the
do we
way.
need to put it plus E?
Try again. Sorry.
I think he's saying, do we need to put plus C?
Yes, of course, yes. I forgot that. I was excited to do all the colors, and I forgot to put the C. I didn't forget actually. I put it already. Right. So there is another more step now. Do you know what it is? We'll tidy up here because we have addition. Yeah. So because we have an addition here, so I can what is it? Make it multiplication. So this will be as, okay, I'll just remove all this writing from here for now. I think that's in the record, it will show anyway, because it's going to be like a video, isn't it? Nope, it's recording anyway. Oh. Right. So this equals ln, what we have 2x plus 1. And this 3, I'll put it as a power for the x plus 2. So it's x plus 2 to the power 3. X plus 2 to the power 3. And that's it. So that's all about the lens. Oh, I have a problem with the lines. And then plus 1 over x plus 2 plus the lovely c. And that's it. Well, basically that's I here, or the integration from the question, you know? Okay? Any questions?
You will lose marks if you didn't do that step.
You lose mark if you, I don't know. I don't think so. I mean, because the step before it's correct. It's just like, I don't know the marking scheme, to be honest, so I can't say anything, but it shouldn't. I can't say things. Because it's not wrong to leave it as it is on the one before. It's just the last step is just making it more tidy. Okay?
Okay, thank you.
You're welcome. Right. What else? Let's see. You have the questions in your book, page 360. So so that's exercise. You have exercise 11.1, page 361. You have a good, nice questions. The more you practice is good. So I want you to do question 2, question 3, 5, and 6. Even if you do more, the rest, that's fine. Yeah, because really with integration, you will need to use all the skills you know. And we still have some more lessons, don't we? Yes, next week. I think I did in the videos now, to be honest, I forgot what I covered already. I covered everything, don't worry. And I think I went in the video through the questions about what is it, integration of the tricks, like when you have sine and cosine and ln, etc. So I want you to make sure to work on these as well. It's important. Right. Yeah. Any questions? No? No questions? Anything you want to ask? I gave you the, I have questions here for you more. I gave you some questions yesterday as well. So I'll put this on the top. Right, so these are the questions for you as well. I want you to practice, yeah? You guys take a picture for it and try to do them, okay? If I have a good time, if I have a time, I mean, I can go through some of them for you. Maybe I will solve it and send it to you, but I can't promise. So I would ask you to work on them and see how we work on them. I don't have the answers for them, so I will just, yeah. Or maybe just to feel more comfortable, if you do the questions from the book, so at least you have the answers at the back. And the one I gave you yesterday, I wrote the answers in colors as well for the yellow thing I gave you yesterday. Whoa. So if you work it out, and if you have any problem, you get in touch with me. I will help you with a pleasure. Okay?
Okay.
Any question, guys? So who's here? Just tell everyone, just tell me your name, please. Where's the questions here? I wrote them. Where are they? Oh, they all gone with the Anzu. Okay, well, you got them anyway. Right, so who do I have?
Well, the
Abdullah raised his hand. How you do this? I don't know. Just a minute. How you raise your hand?
There is an option here in the chat for the participants.
And then,
Lower hand, raise hand.
ooh, I don't have that information. Okay, so I have Abdurrahman, Abdullah. Let me just a minute. Let me stop recording. Stop recording.